This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com. This episode of Fluid Power Forum is also sponsored by Endeavor AI. Endeavor AI automates order entry, quoting, and the quote-to-cash process. Win more, sell more, and save time, all without adding headcount. Head to endeavor.ai to learn more. Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of the show, you can follow us on LinkedIn. We're there at the National Fluid Power Association. And make sure to share interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. If you see an interesting application of fluid power and you want to learn more about it, share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You'll find us on Apple Podcasts. We're on Spotify. We're on all the other popular podcatching services. Wherever you find us, subscribe to the show and then give us a quick rating. Those ratings really do help promote the show and allow more and more of our friends in the industry to join in on these important conversations. On today's show, my guest is Mitch Van Remortel, Strategic Channel Manager at Charter Casting. Founded in 1936, Charter Casting combines expertise in material science with dedicated operational knowledge to produce large, complex iron castings. And Mitch is joining me today to talk about some new innovations in material science, some of particular importance to the fluid power industry, including the importance of high-quality materials, some case studies, and how the future will look. So, Mitch, welcome to Fluid Power Forum.
Thanks, Eric. Appreciate you having me on.
Oh, I'm happy to talk about something I know almost nothing about, material science. So it should be an exciting discussion. Looking forward to having it. Tell our listeners a little bit more about yourself. What is your background?
Yeah, absolutely. So I started my career at Milwaukee Tool, so still in the manufacturing space. Took on different roles within sales, product, and channel management, so very commercial focused. At Milwaukee, I learned a lot about manufacturing, the industries, and really the value of focusing on the customer.
Mm-hmm.
After about 7 years at Milwaukee Tool, was at Brady Corporation, led a team there within channel management, and continued my focus on distribution. I was with Brady for about 3.5 years before seeing an opportunity in a channel management position at Charter Casting, which is where I'm at today. Being from the Milwaukee area, I had heard great things about Charter, but had never found the right timing or opportunity to get into the organization.
Yeah.
Now I've been at Charter Casting about 16 months, so still learning myself. But actually, my first month within Charter was at the NFPA conference back in Tucson back in 2025. So
yeah,
that was certainly an eye-opening experience, and since then have enjoyed my time at Charter, learning the industry, meeting the folks. But yeah, that's kind of where we are today.
Yeah, Charter's been a long-term member of NFPA. They're obviously an important company and in supplying some of the raw materials and for the fluid power industry. So welcome aboard, and I hope the 16 months is not a long period of time, but I'm sure you're still kind of on your learning curve, right?
Oh yeah, absolutely.
Yeah.
I mean, I think whether it's 16 months or 16 years, I think one of the things about being in any industry is continuing to learn and grow, and that's certainly applicable here.
Well, tell us more about Charter Casting then as a company. So, like, what does it do, and what markets is it focused on?
Sure. Turbo Casting is a family-owned U.S.-based manufacturer that specializes in large, complex iron castings and Durabar continuous cast iron products. We operate out of 2 facilities. Our green sand foundry is in Shawano, Wisconsin, just north of Green Bay, and our Durabar facility is in Woodstock, Illinois, about an hour northwest of Chicago. Durabar is produced in both gray and ductile iron grades across a wide range of shapes and sizes. But really what differentiates Durabar is the consistency and quality we've developed through decades of refining both the product and the manufacturing process. And in many ways, Durabar has really become the benchmark for continuous cast iron in the market. Beyond the material itself, Charter takes an engineering-led approach with their customers. We work closely with OEMs and manufacturers to evaluate the manufacturability, performance, and the total cost of ownership so they can make smarter material decisions early in the design process.
Yeah.
As far as industry served, fluid power is probably one of our largest. Outside of that, we do a lot in heavy truck, ag, oil and gas, pump and valve, and many others. One of the exciting aspects of the Durabar product is that we can constantly find new applications where material selection can improve the performance and efficiency for customers.
Well, that's probably one of the key reasons that people should care about what materials they're actually selecting, right? Because it makes a difference. But before we go there, I mean, maybe what is, I'm sorry for such a basic question, what is a casting? What are we talking about? Yeah.
Yeah, a casting is it's a great question, Eric. So a casting is a engineered, designed, full metal product. To be quite frank, more of my focus is with the Durabar side.
Okay.
So iron castings are not part of my, what I would say is specialty. Being on the channel or distribution side, we sell more of the Durabar product line. But castings are essentially molded metal. So they're literally formed in an actual cast and designed the way that the customer needs it. So that way there's no welding that needs to be done. There's really no machining that needs to be done. It's, you make the design of the product, you mold it, and then you pour the metal, you cast it, and right. it comes out as its end product.
And you can do a variety of different metals then in the casting itself. It depends on what product you're going for.
Correct.
Okay.
That's exactly correct.
And then on the continuous bar side, for the fluid power space, like that is used in cylinders. Are there other uses for that material?
There is many different uses for Durabar. Cylinders, pistons, gears,
sure,
hydraulic manifolds. I mean, you name it. If it's being made from, steel or, cast iron, in some cases stainless or even aluminum. Right. Chances are is it could, cast iron could be a direct replacement for their current option.
And that gets into the question about what considerations do people have when they're thinking about, there's a variety of different materials they could use for those pieces of the fluid power system. What differences are important in that space that they should be considering when they're looking at different materials?
Yeah, that's a great question. So material selection is truly important for the overall design of the product, right? So material selection really comes down to what we consider to be balancing 3 major factors: mechanical performance, what we consider to be things like strength, wear resistance, and fatigue life; manufacturability, which is machining efficiency, tooling life, and the production consistency. And then lastly would be life cycle performance, which is durability, maintenance, and the long-term reliability. We think that Durabar sits in a strong position really across all 3 of these major factors when going through the material selection process. So that's really what companies are looking for when they're going through the material selection process, is really those 3 things. But how does my material play into the overall design, performance, and impact for the entire product itself?
Right. Right. So Mitch, those are a lot of things for people to be thinking about when they're making the selection process. when we think about the fluid power system, are there some of those elements that are more important than others? What really should they be focusing on?
Yeah, it's a great question, Eric. Material selection impacts far more than just the cost of raw material. It influences machining efficiency, product performance, durability, maintenance, and ultimately what we called at Durabar the total cost of ownership of the system.
Mm-hmm.
In fluid power, especially, we know that materials play a critical role because components operate under pressure, vibration, heat, and constant cyclical loading. And some great examples of this in the fluid power space are applications like pumps, manifolds, housings, and cylinders, as I mentioned before.
Yeah.
But what many organizations don't consider is that the material selection is one of the earliest decisions in the product life cycle, and usually one of the hardest to change later on.
Yeah.
And when companies think with the end in mind, they can optimize not only their performance and total cost of ownership, but the manufacturability and the long-term reliability as well.
Yeah. I mean, cost of ownership is obviously a huge point of concern for most companies, when they're thinking about investing in something. Can you take us through that a little bit more? Like what are some of the considerations there?
Absolutely. Total cost of ownership is the complete cost of producing and operating a component through its life cycle.
Okay.
So it's thinking about the total cost outside of just the piece price or the upfront price. And one of the most common mistakes we see is when companies optimize around upfront material cost instead of the total system cost. When you take a deeper look, factors like machining time, tooling wear, scrap rates, assembly costs, maintenance, and downtime often have a much bigger impact financially than just the raw material itself.
Mm-hmm.
And for example, many manufacturers initially choose low carbon steels because the upfront material cost is lower, but when they evaluate the full process, Durabar often provides significant savings through faster machining, reduced tool wear rate, improved consistency, and lower scrap rates. And as an example of a real world example, a couple of years ago, we actually worked with a frack pump manufacturer that changed 2 pony rods and a plunger from a low carbon steel to Durabar.
Mm-hmm.
And through the machining improvements and the weight reduction, this company achieved approximately $200,000 in annual savings and reduced annual material weight by roughly 60,000 pounds.
Wow.
Now, this is a great example of, when companies look at total cost of ownership instead of looking at just the upfront price. That's really what we call Durabar, looking at the difference between evaluating price and evaluating value.
Yeah. Well, it sounds complicated, but the math proves itself out in the end, I suppose, right? Right? It's
It absolutely does.
Yeah.
Absolutely does.
We'll continue with our guest in just a moment, but first I want to tell you about an opportunity to engage in the future of fluid power technology. 2 of NFPA's most active committees are our 2 technology task forces, one focused on mobile applications of fluid power, the second on industrial applications. Each of these task forces work on a series of projects that help us better understand the technology trends in these sectors and help us develop the resources and connections that will be needed to keep fluid power positioned as an actuation technology of choice on both mobile and industrial platforms. The Mobile Task Force publishes a series of reports. Their latest was on ways to design more energy-efficient fluid power systems for mobile equipment with electrified prime movers. The Industrial Task Force also publishes reports. Their latest was on ways to minimize and prevent leaks in fluid power equipment. And they have also completed a year-long project that created an independent technology roadmap specifically for fluid power in industrial applications. All of these resources are accessible on our website at nfpa.com/technology reports. But more important is your ability to participate on and engage with the technology professionals that serve on these task forces. New working groups are forming now around the use of sensors and data analytics in fluid power systems, as well as many other cutting-edge technology advances. These task forces are a great example of NFPA's effective forum in action, with NFPA members across the supply chain and an increasing number of their OEM customers actively engaged in creating the technology strategies that help all of their businesses grow. To learn more and to get involved, contact me at elanke@nfpa.com. So how many different options are there out there? I mean, you're invested in the Durabar product. Are there different options that people can look at, and what are their different characteristics?
Certainly. So at Durabar, or in the cast iron space, there's really two primary grades that we focus on, gray iron and ductile iron. Gray iron offers exceptional machinability, vibration damping, thermal conductivity, and sound reduction. It performs extremely well in applications where stability and vibration control are important. Pistons are probably the greatest example of this. Ductile iron maintains strong machinability while also offering significantly higher strength and toughness. Our Durabar 65-45-12 grade is the most common and is often the closest conversion candidate from steel. For more demanding applications, we also offer higher strength grades like 80-55-06 and 100-70-03. Manifolds and swivels are probably the best examples for grades such as these. And the key difference between gray and ductile iron really comes down to the microstructure. The graphite structure within each material changes the way the material behaves mechanically, thermally, and while machining as well.
So, Mitch, I know you did, like that case study that you just described, and you mentioned it there again about sometimes somebody has to make a change. They have to move from the material that they're currently using to some other material that they might want to use. What does that look like at a practical level? How does that happen for a manufacturer that wants to make that kind of change?
Yeah, one of the biggest challenges that we usually see in material conversion is simply overcoming the legacy thinking. Many applications historically that have been designed around steel, that's how it's always been done mentality, or because steel was originally specified on the print, many years ago.
Yeah.
But manufacturers today are under pressure to improve throughput, reduce labor dependency, lower their total cost, and improve reliability, all what seems like to be at once. That's where reframing the conversation becomes important. Instead of asking what's the cheapest material, the better question is what material creates the best overall outcome for the business and for the end customer. And in many cases, once manufacturers test Durabar firsthand and compare the machining performance against steel, the difference becomes very apparent. Experienced machinists especially notice the improvement immediately in tooling life, chip control, reduction or elimination of deburring operations, and the overall efficiency in the machining as well.
You mentioned system level implications for making some of those changes or for using these materials. Can you elaborate on those? What are some of those system level implications?
Certainly. Most organizations evaluate materials at the individual component level,
right.
But increasingly OEMs are realizing that one component can influence the behavior and reliability of the entire system. So that's what we mean by system level implications. So take a hydraulic cylinder, for example. As the pistons move within the cylinder tube, vibration can negatively impact the seals, bearings, surfaces, and the overall system life. Material with better vibration damping, such as gray iron, can help absorb energy and reduce the system instability. That may improve not only the life of the individual component, but the reliability and performance of the entire hydraulic system. That's what we mean by system level implications. The material choice affects far more than the individual part. It influences how the full system performs together over time.
Yeah, it's fascinating. As we talk with more and more people on the podcast here, and we hear more and more parts of the supply chain, if you will, there's like this it's like this group effort that needs to take place because everything impacts everything else in the system as you just described. And I personally previously hadn't thought about, well, what are the fluid power components made out of, and how does that going to affect performance or those things? But you're demonstrating that that's actually a pretty significant consideration going forward.
Right. I mean, organizations need to work together. I mean,
Yeah,
it's increasingly, it's not just a product management or an engineering decision. It's really an organizational decision, right? I mean, you got to think about supply chain operations, also being involved in those conversations
right.
because, once again, if decisions are made in a silo and not through the collaborative effort of the entire organization, it really can have an impact on that, total system level implication that we were just talking about.
Yeah. So I'm assuming in your role you are working collaboratively with your direct customers, the companies that are going to be manufacturing things out of these materials. Do you find yourself talking with then the user of the thing that's being built? Are they part of the conversation as well?
They are.
Yeah.
I work through mainly distribution, so we have a wide distribution network across the U.S., Canada, Mexico, and the globe.
Right.
So I am working a lot with our distribution sales reps to help them figure out why Durabar is better, understand the applications, talk through different types of customer specific questions. Very similar to, I think, earlier on when we were talking about, the engineering led approach. My goal is to figure out the problems, find solutions, and get the right people involved. So that way we can help the, distributor make better decisions with their end customers in mind. So, everything that we do is with the end customer in mind.
Yeah.
We're simply just trying to help our distribution partners identify those, applications that they can go in and solve problems for their end customers.
Great. So what about the future, Mitch? What do you see? Are there new developments coming down in this material science space, or what should we be looking for going forward?
Sure. It's everyone's favorite topic, AI. I
Oh, yeah.
think AI is being discussed almost in every single different industry.
Right. That,
However, the future of material science is becoming increasingly data driven. It's automated and sustainability focused. Additive manufacturing is already influencing how engineers think about part design, customization, and consolidation,
sure.
especially for low volume or highly complex applications. At the same time, manufacturers are placing greater emphasis on the total energy consumption and the environmental impact of a product across its full life cycle, including production, machining, service life, and recyclability. As I mentioned before, we also see AI becoming a major accelerator in material selection and engineering analysis. Historically, engineers may have spent days reviewing testing data and comparing options manually. AI and simulation tools can help companies evaluate materials, predict performance, and optimize designs much faster than before,
Yeah.
sometimes within even minutes or hours. And going forward, the companies that combine material expertise, manufacturing efficiency, and data-driven decision-making will really have a significant competitive advantage in the market.
Absolutely. Yeah. It's weird how it's permeating all different parts of the engineering process in very productive ways. It's fun to watch it happen in the market.
Yeah, it's certainly fun to be a part of. It's, I mean, back even 5 years ago, AI wasn't really a thing, and now, I saw a chart the other day about how fast AI is accelerating or ramping up,
Yeah.
and I mean, it's drastically improving every day or every week. So, I mean, AI, what it is today, will be completely different to what it'll be even 6 months from now.
Yeah, we'll see. Well, note to our listeners, there's no AI in this podcast currently. So both Mitch and I are real people talking to each other. But maybe someday that'll change, right? We'll have AI bots hosting podcasts as well.
Of that, I have no doubt,
Yeah,
Eric.
exactly. Well, I'll be out of a job at that point. Anyway, well, Mitch, I appreciate your time on the show today. It's been fascinating to hear about some of these developments and their applications to fluid power. Any closing comments for our audience about this area or charter casting more generally?
So, yeah, final notes would be take total cost of ownership into consideration when making decisions for your organization. Material selection is drastically important to, not only the total cost of ownership, but the overall performance of the products that you're producing. And Durabar is here to help you guys solve your problems, whatever those may look like, and ultimately help you guys have more money in your bottom line.
All right, well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Mitch Van Remortel, who has been my guest on this show. If you want to connect with Mitch, learn more about charter casting and the material science, the best way to do that is to reach out to him via email, and we're going to put a link to his email address in the show notes for this episode. Remember, if you like our podcast, and we hope you do, please follow us on LinkedIn. You'll get a lot of updates there about the show, about other things NFPA is working on. We're there on LinkedIn at the National Fluid Power Association. And when you're on social media, please share interesting and innovative uses of fluid power with a hashtag called #OnlyFluidPowerCan. That's a great way to highlight what's happening in the fluid power industry and to let us know what kind of topics you'd like to hear addressed on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.